This is the section 1-2 notes for AP statistics, and we are talking about graphs that are appropriate for quantitative data. So on the previous page, on the third page of the notes, we talked about dot plots, and at the top of this page, we just have a little bit of a summary. Dot plots are easy to create as long as you have a small n size. If you have a lot of data in one data set, they can take a while to create, especially when you don't have software to do it for you. You can see the specific data values based on the scale at the bottom, but there are times that in a dot plot you might have to round the data, but they will be in order. You can compare multiple data sets as long as your scales are consistent, and you can see the shape of a distribution, including unusual features like gaps, clusters, or outliers. So the next type of graph I want to talk about is something called a stem and leaf plot, which we generally just call a stem plot. When you make a stem plot, you should always include a key, because the same stem plot you use for this data set as an example could be used for this data set, and I'll show you that after we look at our first example. And similar to a dot plot where I said to make sure your symbols are spaced equally, do the same thing on a stem and leaf plot. You're going to be actually drawing or using numbers, not symbols. So those numbers, or more specifically the digits you use, need to be equally spaced. All right, so in this example right here, it says the data below shows the 3-year rates of return on 21 mutual funds. So in other words, it's pretty much like it's the interest rate on investments that you have. We're going to round each value to the nearest tenth. So the stems are going to be the numbers on the left side of the decimal. So these numbers are going to be our stems. And the leaves will be whatever number ends up on the right side of the decimal after we round. Now I said hint, it often is easier to create the stem plot twice. Once, just get everything organized, and then after that, then you can clean everything up and put it in proper order. So here's what I would start with. If I know I have to start with my leaves, my leaf could be anything as small as a 2, or my leaf could be anything as big as 11. It could be anything as small as 0. So I'm going to have to list my numbers from 0 to 11 right here. So make sure you write them small enough that you make them all fit. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then draw yourself a vertical line. So these values are the stems, and now we're going to draw the leaves. So we have to picture each one of these numbers gets rounded. So this could be 5.4. So after the 5, on the other side of the line, you put a 4. This would be 3.1, 2.4, 4.3, 9.8. All right, now 0.97 is going to round to 1.00. So I'm going to put 1.0. So as it turns out, that's the only one that starts with a 0. I'm actually not going to need that row after all. So this would be 8.6 and 8.3. All right, when you get 2 coming off of the same stem, just put it right after it. So 11.9, and we'll speed this up a little bit. Okay, all I'm doing is rounding each one of these to 1 decimal place. And some people might find that when they do these, they literally might want to put tick marks after they write one of these down to make sure they haven't missed one. This is going to round to 6.0 again, so I'm going to go back here and put a 0. 7.9, and 4.9. So providing I haven't made a stupid mistake along the way, I think that's about what our stem and leaf plot would look like right now. Remember, these are your stems on the left. These are your leaves on the right. I actually know some people, when they make stem and leaf plots, they use graph paper because they want to make sure everything is nice and neat. You don't have to go that crazy. But what I'm going to do now is I'm going to rewrite the 1 through 11 in order. So what I'm doing now is I'm making my final stem and leaf plot. When you make the final stem and leaf plot, your leaves have to be in order from smallest to biggest. And you want to make sure that literally, picture if there was graph paper, you want the numbers to be lined up. So 1.0, 2.4, 3.1, 4.3, 4.9, 5.4. Okay, here we go. So in order, 0, 1, 1, 5. Now they have to be equally spaced. So 0, 1, 1, 5. So I had these kind of spread out more because this 9 and this 1 have to be lined up. So then 7.9. All right, 2, 3, 6, 9. 2, 3, 6, 9. 3, 4, 8. 1, 1, and 9. There's my stem and leaf plot. It actually should have a title. I won't take the time to write it. We'll just say this would have been my title right here. 3-year rates of return. And your key. You can pick any value here. Protocols, people usually pick either the one at the bottom or the one at the bottom, meaning the smallest number or the largest number. And I'll use this one. 11/9 stands for 11.9%. Now, what I said up here is I said the same stem and leaf plot could be read different ways. We know that every one of these is 2.4, 3.1, but without that key, for all you know, maybe that 8/2, maybe it stands for 8,200, 7,900, 5,400. Maybe it stands for 5.4 million. 6.0 million. Your key has to tell someone how to read the stem and leaf plot. Now, the purpose of it is if you turn it sideways, it should kind of sort of have the same look as a bar graph. That you could look at this and say, well, if I kind of go around the outside, I can kind of see the shape. And it actually looks like it might be somewhat bell-shaped. Maybe a little left skewed. Looks like maybe it's peaking here and it's maybe tapering off. So if I were to write the description of this, I would say it looks like it's somewhat symmetric with a slight left skew. And that's the purpose for doing this, so that you can actually see that. And the nice thing is you actually see the numbers that the graph came from. Besides rounding, another option, this is actually what the program Minitab will do, is it truncates. And truncate means it just chops the number off. So instead of rounding this to 5.4, it would literally just chop off the 7 and call it 5.3. It wouldn't call this 3.1. It would just chop it off and call it 3.0, 2.4. Truncating literally just means don't look at the last decimal place if you don't want it. It just says cross it off. Now you might say, well, that's horrible. Now it's going to change the look of the graph. Not dramatically. I mean, look at the 5.4 that we graphed. It would now just say 5.3. Now the 5.99, okay, that would now be graphed as 5.9. That could change it a little bit. Instead of a 6.0, you'd have a 5.9. Instead of that 1.0, we would have a 0.9. So we would have had a slight gap in the graph. So it can affect it a little bit. And that's also, by the way, why we don't call it an outlier if we don't mathematically establish that, because it could just be a mild gap. The next thing I want to talk about with stem and leaf plots is something called a split stem. Sometimes when you make a stem and leaf plot, you might not see a shape emerge. Or maybe you just don't see some of the unusual features that might be there. So the data below shows the number of people in line at 35 different rides at an amusement park. A stem plot of the data is also included. And I noted here, I got this from a website called calculatorsoup.com. Your calculators don't make stem and leaf plots, but at this website, and there's lots more online, you just type in the data. I copied and pasted it from Excel, and it will make the stem and leaf plot for you. It put everything in order. It made the stems, the leaves. Now, it didn't make the key. I added that, but it's super, super easy. Now, when I look at this stem and leaf plot, I'm going to turn this one sideways also. Do I see a shape here? Well, it definitely looks unimodal. And if I try to draw a shape around here, I think it's probably looking kind of like a right skew because it's definitely tapering down on the right, but it sure is not getting a tail like we sometimes look at a right skew. So on the next page, we're going to look at what a split stem graph would look like for the same data set.